As we move on to problem 4, the only thing that's going to change about problem 2, it's going to be very identical to problem 2, is that in problem 4, I'm going to throw an absolute value at you. Well, you know that absolute values take what type of shape? I hope you remember that they take a V shape. So I'm going to write that on there to remind myself. And I'm going to ask myself what this looks like. This should look like a straight line. Okay. Now, one thing I should notice is that there is no x in this problem. You guys should remember if there's no x and there's just a y, that this straight line is going to look like this when I graph it. Let's go to where y is 3 and draw a hash mark. 1, 2, 3 on the y-axis goes right here. It's going to be a solid line because it is equal to. The slope is 0. You remember all of this from chapter 2, I'm sure. There it is, y equals 3. And now it says that the answer is anything below y equals 3. So if I lightly shade, I know that my answer is going to be anything down here so far. Just real lightly shade it. Don't darken it in yet. Alright. Now for this one. To graph the second one, I need to find a vertex and I need to find a slope. The vertex is opposite of what's with x, so positive 1, and then what's in the back? 0. The slope is what's out front, 1 over 1 in this case. So I'll go to the point, 1, 0, which is right here, over 1 up 0, and I'll use my slope to go up 1 over 1, up 1 over 1. Remember what I told you, students make a mistake as they just draw a straight line. Remember this is a V shape, so on the other side I have to go up 1 to the left 1. You can go until they meet, or you can make your graph a little nicer and extend it out. This again will be a solid line. And it is a solid line because it is equal to. Get your arrows on there to indicate that you know that it extends forever. And this says that it needs to be above because it's greater than. So put your pencil on the vertex, there it is, and shade above it. That would be anywhere in here, above the vertex. So you should see where the area overlaps is inside of this little triangle. Common mistake, if you want to write down a common mistake so you don't make it, a common mistake is students always think that the answer is inside of the V. That doesn't always happen. You have to make sure that you pick appropriately. If you wanted to check, you could plug in, for example, over 1, up 1, 2. If you wanted to check, you could plug in over 1, up 2. And you will see that it works for both the equation. And I shouldn't say both equations, I should say it works for both inequalities, if you were to plug it in. Alright, the got it, we have one more to do. I see a y equals mx plus b, so this is going to be a straight line. This one's going to be a diagonal line because it's y equals mx plus b. And this is an absolute value, so this will be V-shaped. Let's go ahead and graph our straight line first. Your y-intercept is 1, and your slope is negative 1/3. So let's go up 1 and make a dot, and down 1, run 3. Down 1, run 3. You can take that the other way if you wanted to. It's not necessary, but it does sometimes make your graph look a little prettier. Let's see, a broken line on this problem. Be careful with your slopes. I have noticed that some of you don't do rise over run, you do run over rise. So just be careful that you do rise over run for slope. So there's my broken line. And I shade, since it's less than, I shade very lightly below. You may wait to shade until the end, or you can shade now. The last one we're going to do is the V-shaped graph of our absolute value. We'll find the vertex to be 1, 0. It's opposite of what's with x, plus what's in the back. And in this one, our slope is 2 over 1 because of the 2 on the outside. Go over 1, up 0, make a dot. Now use your slope to go up 2 over 1, up 2 over 1, up 2 over 1. Remember that this is a V-shaped graph, so we also have to go up 2 to the left 1, up 2 to the left 1. And again, I will be connecting with a broken line. Okay, I just filled my other line in a little bit to make this one easier to see. So I will be using a broken line because it is just greater than, it is not equal to. So just give it little dashes on the way up. There it is. And do it on the other side as well. Little dashes on the way up. And now we have to figure out where to shade. If I put my pen on the vertex, it says it's greater than the vertex. So it's anywhere above the vertex, which is inside my absolute value. Look how tiny this little answer is. It's just this little itty bitty shaded area inside where the shading overlaps, which would be right in here. That's it. It's that little itty bitty area inside. So you can write here, it might be beneficial for you to say, or circle it, the answer's in there. Because it's so small, the answer is right inside of there. But you should also note that this time the boundary lines are not solutions. And this time the boundary lines are not solutions because they're not equal to. Okay.